Welcome back. Let's continue. We were talking about equations of motion and how important they are. That's where you gain more marks in this section. That's where calculations are based. And please be careful on this one. We say the equations of motion, and there are 4, and all of them have got 4 quantities in each one of them. Therefore, but all the quantities in equations of motion, they are 5. And remember, we said in all scenarios you will be given what? Either VI, or we have to calculate it. Now, one thing, because there are 5 quantities and each equation has got 4, means that there's a missing quantity in each one of them. The first one, there's no is missing delta y. I mean that if you are given any information between 2 points and there's no delta y, then you'll use the first equation. The second equation, everything is there then, but there's no delta t. I mean that if you are dealing with any 2 points, between those 2 points you don't know the time taken, then from start to finish, then you're going to use the second one. And that is the most common one. Please practice using this one. You will get more marks in future. The next one is this one of delta y, then which is missing VF. You can see that every variable is there except VF. The last one, there is no A. So mainly when A is 0, you can use the last one, or you can even use the second last one. So that one will be the case. Hopefully now you get the gist of this. Remember, we say A is always downwards. Therefore, what you should know in projectiles before we go to the scenarios of projectiles, we say at all times ignore air resistance. Especially in grade 12, all questions will tell you that air resistance is ignored. Fine, meaning that now if it's the motion of an object, and that object becomes a projectile. If it's the motion of that the object, the projectile, and that is moving also freely. So we've got only 2 definitions in this section, so we'll talk about that one. A is always 9.8 meters per second squared downwards at any given point. Please, they'll give you 2 marks for saying this one. The last one is that always choose direction. Remember, we are guided by the direction of VI. In terms of the motion, we said if you want to make it simpler for you, we say if you want to define a projectile, obviously we say a projectile will be an object in motion. Fine, we'll talk about the last part. Whereas a free fall will be a motion of an object. That is how you make it life easy for you. So free fall is a motion, object is projectile is an object. So the last part is the same, whereby only, the word only should be there, only gravitational force acts on it. Only gravity acts on it. So that is the last part. Only should be there, is a key word there in the definition. If your definition is there but there's no the word only, now that you are wrong somewhere. So that is how you get the 2 marks in this section, by defining. Now let's come to the scenarios. In an exam, they would like you to know all these 4 scenarios. There are 4 all in all. They are very easy. You need to know 1, dropping of the ball. Dropping of the ball. That's the first one. The second one will be the one where now the projectile is projected upwards. Dropping of the ball means that you will have this. If you are starting here, it's a half a motion. Is either you'll drop the ball with the initial velocity of 0, that's when we say the ball is released, or you drop the ball in the air with an initial velocity that is not 0. The ball is projected vertically downwards with the velocity of this one. Therefore, this becomes our initial point, and when it hits the ground, that's our final point. So we'll deal with this one. Now the second one scenario is where now the ball is projected at this height and then come back to the same level. Now in this scenario, we know that if the ball is going up at 10 meters per second, therefore when it reaches the same level on its way down, it will be moving at also 10 meters per second. But in this case, it will be negative. The third scenario is where now the ball is projected from two different levels. It's normally projected from here as initial and then reaches the ground here as the final, or the ball is projected here and then also reaches the final here. So as long as the initial and final are not at the same level, that is the third scenario. The last one is about the bouncing ball. Bouncing ball. In the bouncing ball, this one normally we say is a combination of any of these ones. Now this is the first scenario, the second scenario, the third scenario. In this case, you can see that now here is only half, mean that is half of this one. So that's the first one. And then this one mean that the second one is a combination 2 of this one, half plus half. This one we've got half, small half, and the big one. So in this case, we say if the ball is projected this way, therefore at the top here, the final velocity will be 0 on its way up. But when it starts from here coming down, the initial velocity will be 0. That's what you should know. And because this one now in maths, they talk about what's the word for maths? But this one is the mirror of this one. I forgot that word now. Then it means that if it takes 3 seconds to reach the top, it will take also 3 seconds to reach the bottom. I mean that if the whole trip is 6 seconds, half of the 6 seconds is to the top and half of the 6 seconds will be to the bottom. That's how this one works. Fine, meaning that if you apply this one in this one, I mean that if I release this one at 8 meters per second here, 8 meters per second, at the same level this side, it will be moving at negative 8 meters per second. That's how you apply this one in this. So far is okay. Then we can get maybe to a typical question, like in this case to say, always remember, we say in all this, A is always downwards. That's what you should know. And it's 9.8. But for calculation purposes, if upward is positive, A is negative 9.8. If downward is positive, A is positive 9.8. That's what you should know for calculation purposes only. So that's what we do. Then when we get to the questions in this case, to say, let's take an example, first example of this one. The first example will be, now a ball is dropped from the roof. A ball is dropped. A ball is dropped from the roof. The roof of a 100-meter building. So high building, so 100-meter high building. Fine. Ignore the air resistance and calculate. Ignore air resistance and calculate. Now the moment we ignore air resistance, you can underline that one. Therefore it means that now that ball becomes what? A projectile. This ball will be a projectile now. Projectile, I mean that is accelerated 9.8 meters per second squared downwards. Now they say calculate the velocity of the ball when it hits the ground. If we analyze this one, we can say, oh, fine, all the time have all the 5 if you want to get it right. Vi, Vf, A, delta t, and delta y. Therefore, in this case, Vi, because it's dropped, it will be 0. And the ball start by going downwards. Vi is downwards. Then I take downwards as positive. Then A will be positive 9.8. Fine. What else is given from the statement is the height of the building. The height of the building here is given. It's 100 meters. Now I'm given 3. We said for you to use any of the equation of motion, you need to be given at least 3. I know 3, then I can even create a question. Obviously, the question can ask me about the final velocity with which the ball will hit the ground, or the time it takes for the ball to hit the ground. On this one, they say calculate the velocity of the ball when it hits the ground. Find the final velocity. That's the first question. Find the final velocity. Now we go for the formula. Can you look at this one? We are given this, and this one. Then we need the final. So you go for the formula without what? Delta t. Or go for the formula with Vi, Vf, A, delta y. There's only one formula in that case. You just go and copy. Vf squared equals to Vi squared plus 2a delta y. Therefore, Vf squared is the one. Vf is the one I'm calculating. This will be 0 squared plus 2 into 9.8 multiplied by 100. Then you use your calculator in that case. Let's calculate, and then we'll get, if we use the calculator, Vf will be the same as 44.27 meters per second. That will be the Vf. Now, the second question you can always create, in this case, based on the given information. We say you can either calculate Vf or delta t. So you expect the second question to say calculate the time taken. Obviously, they say so how long it takes the ball to reach the ground. So find the delta t. Find the time taken. Find the time taken. Time taken to reach the ground. Reach the ground. Therefore, we can, in this case, advantage with this one is that now we know 4. Remember, this one is 44.27. There is what you call positive marking. Even if this one is wrong, if you use it to calculate time in any of the formula where time exists, then it will be correct. So now we go for the formula with delta t. The easiest one will be the first one. To say the first formula will say Vf equals to Vi plus A delta t squared. Vf is 44.27 equals to Vi is 0, and then plus A, which is positive 9.8 multiplied by delta t. Sorry, there's no t, delta t squared. Then from here you use your calculations. Then delta t will be 4.52 seconds. This will be the time taken to reach, in this case, the ground. Remember, we say in this case, from the equations of motion, any equation of motion with time, because we have got 3 equations of motion with time, you can see that the first one is having delta t, the second one, the third one is having delta t as well, and then the fourth one is also having delta t. So you can use any of these 3 equations to find delta t, as long as you have got 4 quantities. If you have already calculated the Vf, then you can do that. So I hope and believe it becoming clearer and clearer. That's the gist of projectiles. So we'll do also questions that are related to this, but this is the first part of projectile whereby the object is sort of released or is dropped with initial velocity of 0. So thanks a lot, until next time.